Welcome students. In Unit 1 of Module 2, we discussed about what is meant by fruit number, and then we discussed about what is meant by specific energy, and we discussed one problem in specific energy also. Okay. In Module 1, we discussed about what is meant by open channel flow. Then in open channel flow, types of open channel flows, it depends on time, steady and unsteady, depends on space, uniform and non-uniform, like that. We discussed about so many types of open channel flows. In this module, we are going to discuss about uniform flows. First, we discuss what is uniform flow. It's nothing but we discussed about uniform flows in first module itself. Again, I am revising flow parameters like velocity or depth of flow or bed slope is constant with respect to space. That is called uniform flows. We can denote this in mathematical form as dV by dou S is equal to 0, like that. Dou depth, I am mentioning, I can use depth as Y or D. I can use any one term. Divided by dou S is equal to 0, like that. Dou I divided by dou S is equal to 0. I is nothing but bed slope. So this is uniform flow condition. Okay. Now we already discussed what is meant by uniform flow. Now we will go for uniform flows. Okay. In uniform flow, we know what is uniform flow. In uniform flow, mostly problems are solved. Here, whatever may be the problem. In applied hydraulic engineering, we having two formulas. I know what is Q is equal to AV. Here, Q is nothing but discharge. Area is nothing but, cross-sectional area. V is nothing but velocity. We already know this. Okay. So we have for calculating velocity, we having so many formulas. In that case, very important one formula is called chezys formula. Chezys, CHEZYS, chezys formula. So we are going to now discuss about chezys formula, and we are going to derive chezys formula. Then after deriving chezys formula, we are going to solve some problems in chezys formula. Okay. Now we will discuss about how to derive chezys formula. Before deriving chezys formula, I am drawing one open channel. It is bed. So I am taking, this is I. This I is called bed slope. Bed slope. Okay. I am taking water up to a depth of, actually we can use as D, or I can use as Y. Generally we will use as Y. This is depth, like that. This is it's cross-sectional area. I am taking one prismoidal shape. Okay. Now here we having two forces. First thing is, this is I. We know this weight of this object acts towards gravity. Okay. In this, if I am taking this W, if this is I, so surely the term which is parallel to bed is, okay, if this is I, then again this will become I. So this this horizontal quantity will be equal to W into sin I. Because of this W into sin I only, flow is happening in open channel flows. If this W into sin I value is equal to 0, then automatically the flow of open channel will not happen. So force causing flow is equal to, this is the one which causes the flow, W into sin I. I know what is W. W is nothing but weight. Weight is nothing but unit weight times volume. If I am taking this length as L, then this cross-sectional area times length is equal to volume. So unit weight times the volume. Volume is nothing but area times length. So this value will be equal to this W into sin I. Okay, this is a force causing flow. Okay, this only causes the flow. Okay, now we derived what is force causing the flow. Like that, that force causing the flow, there will be some resistance because of friction between water comma beds. There will be force resisting the flow, friction force. Now for deriving that friction force, what we have is nothing but one term we are taking that as resisting flow. It's derived by experiments. So force resisting flow, force, I am taking this as force causing, this is as force resisting. This force resisting will be is equal to what means K is nothing but constant, times P is nothing but perimeter, times L means length, times velocity, the square. Okay, now what I am going to do is I am equating force causing the flow and force resisting the flow, because there is no other forces involved in this open channel. So if I equate both terms, then I will get K into P into L into V square is equal to unit weight times area times length times sin I. For smaller angle, for small I, sin I is equal to I. So I am substituting sin I instead of sin I, and I am cancelling this L, and if I equate V square is equal to gamma divided by, I am taking this K in this side, into area divided by perimeter into sin I. I am taking sin I as I, because for smaller angle sin I value will be is equal to I. Okay, now if I need V is equal to root of gamma divided by K into area divided by perimeter. I am taking this term, very very important term, area divided by perimeter is called hydraulic radius. I can denote this as R or M. I will use as M, but in some books they are mentioned as R also. So here I am taking this as M times I. if I take this as constant, I am taking out, if I am taking this as a constant, C times root of mi. C value will be equal to root of unit weight divided by K. Okay, this is chezys equation, which is very, very important for open channel flows. Particularly, this chezys formula is applicable for uniform flow conditions only. For uniform flow, chezys formula is very, very important. V is equal to C into root mi. Here, C is nothing but chezys constant, m is nothing but m or capital R. That is nothing but hydraulic radius. I is nothing but bed slope. Okay. If I am taking this chezys formula, V is equal to C times root mi. Here V is nothing but velocity, C is nothing but chezys constant, m is nothing but hydraulic radius or hydraulic mean depth, which is equal to area divided by wetted perimeter. Okay. Then I is nothing but bed slope. For calculating chezys constant C, if in question or in problems, if C value is given, then I can directly substitute that C value. If C value is not given, then what I have to do is I can calculate either using Bayesian's formula or Cutter's formula. If I take Bayesian's formula, in Bayesian's formula, C is equal to 157.6 divided by 1.81 plus K. K is nothing but Bayesian's constant that will be given if question is based on Bayesian's formula divided by root m. M is nothing but hydraulic radius. Here I am using as m. In some books they are referring that as capital R also. Like that, in Cutter formula, C is equal to 23 plus 0.00155 divided by I plus 1 by n divided by 1 plus 23 plus 0.00155 divided by I into n divided by root m. Okay, I can either use Bayesian's formula or Cutter's formula. It depends on whether Bayesian's coefficient given or Cutter's coefficient given. In some cases, they will simply directly they give chezys constant C. Okay, if that case, we can ignore Bayesian's or Cutter's formula. Now we will discuss about what is the dimension for Bayesian's chezys constant. It's a important 2-mark question in some cases. I know velocity. For velocity, unit is meter per second. For chezys constant, I have to derive. I know m is nothing but area divided by perimeter. Area's unit is meter square. Perimeter's unit is meter into I. For I, no dimension. So here 1m cancels. So C into root m divided by s. So C is equal to m divided by s into root m. If I cancel, I will get C is equal to m power of s power 1 by s. I am taking s 1 by s as s power minus 1. So I will write its dimension as meter. Meter is nothing but linear dimension L power of its time dimension t power minus 1. This is dimension for chezys constant. It may be asked in case of 2-mark questions or 1-mark questions. Okay, it's another important thing which we have to discuss. Okay, in next we will discuss about Manning's formula. Then we will solve some of the problems by using chezys formula. In Manning's formula, sometimes question may be asked if velocity can be calculated using Manning's formula also. In Manning's formula, velocity is nothing but is equal to 1 by n. This n is called Manning's coefficient. Manning's coefficient times m, small m. I know what is small m. Small m is nothing but hydraulic mean depth or hydraulic radius power 2 by 3 into I power of. I is nothing but bed slope. Okay. If I equate both velocities, then I will get this is the relationship between chezys constant C and Manning's coefficient capital N. Okay, this may be also asked in any 2-mark question. What's the relationship between chezys constant C and Manning's coefficient N? So try to understand both. What's the relationship between both chezys and Manning's formula. Now let's go for some problems we can solve using chezys formula. Okay, in this case, determine discharge through a 2 meter wide, 1.2 meter depth channel with bed slope of 1 in 12,000. Take Manning's coefficient equal to 0.012. In this case, they are given they are asking for discharge. I know discharge is equal to area times velocity. Here, width and depth given. If width and depth simply given, that cross section is nothing but rectangular cross section. With width value is 2 meter, depth value is equal to 1.2 meter. So I can calculate area. Area is nothing but 2 into 1.2 meter square. I can use this. Then V, I don't know velocity. If I know velocity, then problem is simple. Then for calculating velocity, they given Manning's coefficient. So I am using Manning's formula for velocity. Velocity is nothing but 1 by n. N value is also given 0.012 into 1 by n, m power 2 by 3. I mean, I know what is m power 2 by 3, I power half. Here I value is given. I value is bed slope 1 divided by 12,000. M value is not given. We have to calculate M. M value is nothing but is equal to area divided by perimeter. I know what is area. For perimeter, this 1.2 meter plus this 2 meter plus this 1.2 meter. So totally perimeter is equal to 2 times 1.2 plus 2 meter. So I will get, by using this I can calculate what is area, perimeter and M. If I substitute this M value, I will get velocity is equal to 0.51 meter per second. If I substitute this velocity in this case, if I know area 2.4 meter square, velocity I know. If I simply multiply, then I will get this Q is equal to 1.22 meter cube per second. It's a very basic formula, so you can solve your own. I just gave idea about how to solving this problem. Now we will discuss about next problem. Here in this case, it's a second problem. Determine discharge through a 8 meter wide and 2 meter depth rectangular channels. Okay, in rectangle channel with bed slope of 1 in 950. Take chezys constant is equal to 50. It's a very direct formula because here they are given as chezys constant. So they are asking for discharge. I know for formula discharge, area times velocity. It's rectangular cross section. Width is given as 8 meter, depth is given as 2 meter. Then I can calculate area is equal to 8 into 2, 16 meter square. But I don't know what is velocity. If I know velocity, then problem is over. For velocity, they are given as chezys formula, chezys constant. So I know what is chezys formula. V is equal to C times root of mi. Here chezys constant is given as 50. This value is given. I value is 1 in 950. That means 1 divided by 950. I value also given. M is not given. We have to calculate M. What is M? M is nothing but area divided by perimeter. I know what is area, but perimeter is not given. 2 meter plus 8 meter plus 2 meter. This is nothing but perimeter. So perimeter value will be is equal to 2 times 2 plus 8. Why I am using this 2 means this 2, then this 8. If I add, then I will get perimeter as some value. If I substitute, then I will get velocity value will be equal to velocity value will be I don't know exactly what is velocity value, but if I substitute this velocity in this, then I will get the discharge value is equal to 29.93 meter cube per second. Okay, Next, very important and biggest problem, that is nothing but trapezium shape problems. We will discuss about the trapezium shape problems as third problem. Okay, just by taking third problem, if you read, a trapezoidal channel with bed width of 3 meter and side slope of 2 horizontal is 1 vertical carries water at a depth of 1 meter. If bed slope is 1 in 700, comma C is nothing but chezys constant is 52, then determine discharge. This is a problem which is given. Okay. For this case, first we have to draw diagram. After drawing diagram only, we can able to solve problem. It's a trapezium section. So I am drawing trapezoidal shape. Here they are given bed width. Bed width is entirely different from top width. This is top width. Okay, I am naming it as A. Okay, because we have to split this entire area into one triangle, and this makes it simple. A, B, C, D, E, F. Okay, here they are given bed width. This is bed width, this is top width. AD is top width, but here bed width is 3 meter and depth is 1 meter. And they given side slope. Side slope is nothing but this value, 2 horizontal, 1 vertical. Okay. If I see this value is 1 meter, I don't know but this value. But here they given as 2 horizontal, 1 vertical. That means here for this triangle, okay, for this triangle, horizontal to vertical ratio, and for this triangle, horizontal to vertical ratio should be same. In that case, CD divided by CF. So that means CD is horizontal, this is vertical, divided by this horizontal to vertical ratio should be equal to this horizontal to vertical ratio. This means 2 horizontal by 1 vertical. I know CF value is 1. If I substitute CF value as 1, I will get CD is equal to 2 meter. Then I can get CD is equal to 2 meter. This value is 3 meter, this value is 2 meter. Okay. Here, then I can calculate area easily. How I can calculate area? Area is nothing but this is one triangle shape, half into 2 into 1, plus this is one rectangle shape, plus 3 into 1, plus again another triangle shape. Again half into 2 into 1. 5 meter square. Then I easily calculate perimeter. Perimeter is nothing but AE plus EF plus FD. I am just erasing this value. I know what is A value. A means area. Area value is nothing but 5 meter square. Now I calculate perimeter. Perimeter is nothing but AE plus EF plus FD. How I calculate AE? AE is nothing but this value I know 1 meter. This value is 2 meter. By using Pythagoras theorem, AE value is equal to root of this square plus this square. 2 square plus 1 square. Plus EF. EF value is given as 3 meter. Plus FD value also by using Pythagoras theorem, root of 2 square plus 1 square. Here value is 1 meter 1. This value is 2. So I'll get. By using this, I can calculate perimeter as 7.47 meter. If I know area and perimeter, then I calculate M, hydraulic radius, that is nothing but area divided by perimeter, which is equal to 0.67 meter. If I know this, then I can simply calculate discharge. Discharge is nothing but area times velocity. Area I know. For velocity, they given chezys formula C times root of Mi. I know what is M. I know I value is given as 1 in 700. If I substitute, then I will get discharge value as 8.04 meter cube per second. So, students, so far we discussed about what is meant by uniform flow. Then chezys formula, which is very important for calculating discharge in uniform flow. Then we discussed about chezys formula. Then we derived chezys formula. Then we we saw how to calculate chezys constant using Manning's or Cutter's or Basins formulas. Then we discussed 3 problems using chezys formula and Manning's formula. If problem is in some cases discharge may be given, but either I value or bed slope value or cross sectional value may be asked. For that case, what we did so far, we have to do everything in reverse manner. That's it. Okay, thank you. In next module we will discuss about most economical sections. Thank you.